Okay, this section, we're just discussing about the hydrostatic equation. Hydrostatic equation, we're just trying to see if the change in the pressure intensity between two levels is proportional to the vertical distance between them. So this is what you're just going to see. Let's see what does that mean exactly. Imagine that we have like the depth of the water here. So we have like a water surface at the top, and we have a distribution of the pressure as we discussed it before at point 1 and point 2. We're just going to see what is the the pressure head at different levels and how is it proportional to let's say if you have like a datum or reference level at the bottom, how they're just going to change compared to like the point 1 and point 2. So this is like might be very interesting for you. So the pressure at point 1, let's say, if you're just going to do that, P1 is like the formula we're just going to use is rho g H1. So we're just going to use this one, rho g H1. And H1, imagine the whole depth or the total depth is equal to D. You can easily write that one or substitute H1 as D minus Z1 if you're just going to take the distance or the height from the bottom, D minus Z1. So you can substitute here in this formula. And for point 2, you can write the P2 is equal to rho G H2. And H2 easily, again, here can be substituted with rho G, and H2 can be substituted with D minus Z2. Okay, H2 can be replaced with that one. So imagine we got this one and this one. So if you're just going to take away or take the difference of the P2 minus P1 in here, so you can just write rho G using the second parts that we derived here, open bracket, D minus Z2 minus rho G, open bracket, D minus Z1. So if you're just going to factor rho G, so we can write rho G, open bracket, D minus Z2 minus D plus Z1, okay? And the D and D cancel out. You can see, write it here, rho G minus Z2 plus Z1, okay? And if we can just take the rho G inside the bracket, or sorry, not inside the bracket, take the minus outside this bracket, we can have like the minus rho G inside the bracket, Z2 minus Z1. And if we're just going to substitute the minus P1 to the right hand side and negative part of the Z2 to the left hand side, so like all the terms with the 1 in one side, all terms with the index 2 on the right hand side, we're just going to have P1 over rho G plus Z1 is equal to P2 over rho G plus Z2. So these are like the 2 terms or 4 terms out of like the 6 terms of the Bernoulli or energy equation. But all of them, we just only looked at the hydrostatic equation. So you can see here the pressure at one point plus the distance or the vertical distance from the reference from the datum is equal to the pressure at point 2 plus the distance from the datum reference. So that's like a total the hydrostatic equation.